Okay, so I'm going to give you a quick introduction on some practice problems before you start your problems on page 201, the try these 1 through 9, and hopefully this helps you get started. So looking at example 1, we have 3x plus 12. If we want to factor out the greatest common factor of both terms, we have the number part, which is 3 and 12. 3 is the greatest common factor of 3 and 12, so we would pull out the 3. And in order to pull out a variable, both of them would have to have a variable with an exponent. But 12 does not, so we cannot pull an x out of that. So this 3 is our greatest common factor for both terms. Then in order to get 3x back, we would put the x here. 3 into 12 is 4. And this would be our factored form of 3x plus 12. This is our final answer. This is like undoing the multiplication or getting something into a form that looks like you're about to distribute it. This is the factored form. So 3 parentheses x plus 4 is the factored form. If we wanted to check our answer, we could do the distributive property. 3 times x would be 3x. 3 times 4, positive 4, would be positive 12. This is correct because that's what we had to begin with. Sometimes we end up with a polynomial that we can't factor any further, meaning there are no common factors for both terms. So if you look at 7x and 9, they are relatively prime, and we have nothing to pull out besides a 1, which we don't do, and I would just answer prime here. And if we had a 7 and a 9, but 9 had an x, then you could pull out an x. But in our case, 9 does not have an x. 7 and 9 are relatively prime, so we have the final answer would be just to write they're prime, and that's as good as it's going to get. Okay, for number 3, we have numbers, and we have 2 different kind of variables. We just look at them one at a time. So with 15 and 30, the greatest common factor is 5. I'm going to write that out. For a squared and a to the first, remember there's a hidden 1 there. A to the first is the smaller one, so we can put a there. I'm not going to write the 1. Then we'll look at the b. We have b to the first and b to the first. So both terms at least have a b to the first term. So we are going to pull that out, factor it out. 5ab goes into 15a squared b, 3. 5 times 3 will give me my 15. What will give me my a squared? Another a to the first. And b, I won't write any b there because we already have a b to the first right here. Then 5ab goes into 30ab how many times? Minus 6 times because I already have an AB here. Now quickly mentally check 5AB times 3A is going to be 15A squared B minus 30AB, and that is exactly what I wanted. So this is my factored form. For number 4, we've got 3 terms, and that's okay. We're going to do the same thing, look at 3 terms and look at what they have separately, the numbers and each variable. So in front of this first term and the third term are 1s. So 1 and 3 don't have any common factors other than 1, so we're not going to pull that out. You could write it if you want. You can write a 1, but we don't need to. So now we can look at the x's. We've got x squared, x to the first, and x to the first. So every term at least has an x to the first. So that's my x to the first. Then I have a y to the first, a y to the first, and y squared, which means every term has at least a y to the first. That is what I'm factoring out. xy can be factored out from all 3 terms, and then I figure out what goes in between. xy goes into x squared y, x times, because we have x to the first times x to the first will be x squared times y, plus I already have xy pulled out. I just need a 3 right there. And then plus, in this case, we only need an extra y term. Now, I did that a little bit quick, but let me check that. I'm going to use a different color. I'm going to show you how that worked out by checking it. X to the first times x to the first is going to be x squared y for that first term. Then xy times 3 is a positive 3xy. And then xy times that last term will be a positive x, and it's y to the first. Y to the first will be y to the second. So you can see, if I go ahead and erase these lines up here, this is indeed what we started with. So this blue factored form is correct. That's the factored form, and that's your answer. Let's look at example 5. We've got 12, 24, and 18. The greatest common factor will be 6. Then for the x, we've got x to the third, x to the first, x to the third. That means all the terms at least have an x to the first. Y to the third, y squared, and y to the fifth. All of them at least have y squared. Remember, we're looking for the one that at least all the terms have. So I pulled out my factored monomial, and then I'm going to determine the inside. 6xy squared goes into this first term. We want a 2 here, an x squared term, and then a y. So that when we would multiply it, it's 12 x to the first times x to the second is x to the third. Y squared times y to the first is y to the third. Exactly what we wanted. For the second one, we need a 4. We don't need another x, and we don't need another y. For the last one, we need a 3. We need x squared, and we need a y to the third. Because y to the second times y to the third is y to the fifth. Remember that. So this is our factored form, and we're done. As long as you pull out the greatest common factor and you factor it out correctly, that is the factored form. Always remember to double check your work. I'll check it here one last time. 6 times the first term, 6xy to the squared times 2x squared y would be 12. X to the third, y to the third, yes, that's correct, minus 24 xy squared, that is correct for that second. And for the third one, it is positive 18 x to the third, y to the fifth, which is exactly correct. Okay, so go ahead and try these problems on page 201, numbers 1 through 9. If you have any questions at all, send me an email and we can talk, or I can answer them over email or video chat.